Myself, Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. Today we are going to learn the subject 3D Printing and Design. The subject code is CCS 331, Regulation 2021. In previous videos, we have seen Unit 1 and 2. Today we are getting into the Unit 3, Inject Technology. In this unit, the first topic is printer, and today we are going to learn printer in detail. So first of all, we can see what is inkjet technology. Inkjet technology in 3D printing is an additive manufacturing process in which microscopic droplets of liquid materials are precisely jetted through a print head to form a 3D object layer by layer. Similar to conventional inkjet printing, the material is deposited only where required and it's solidified using UV light, heat or chemical bonding. This technology offers high resolution, smooth surface finish and the ability to print complex geometries, making it suitable for prototyping, medical models and full color parts. Next, we can see this printer in elaborate. So in printer we are going to see about working principle, positioning system, print head, print bed, frames and motion control. In inkjet 3D printing, the print head is mounted on an XY positioning system that precisely moves across the print bed according to the digital model. The print head jets tiny droplets of material or binder only at required location to form a layer. The motion control systems synchronizes the movement of print head and the print bed, while the frame provides structural stability and alignment. After each layer is deposited and solidified, the print bed moves down slightly and the process repeats layer by layer until the 3D object is completed. Next, we can see about the working principle. In this process, the printing material is jetted as microscopic droplets through a fine nozzle in the print head rather than being extruded continuously. As a print head raster scans across the print bed, material is selectively deposited to form each layer, building the object in a precise layer by layer manner. A wide range of materials such as polymers, dielectric nanoparticles, and conductive nanoparticles can be deposited, making inkjet-based 3D printing highly adaptable for functional and multi-material applications. Next, what is raster printing? So raster printing is also known as a bitmap printing. Represents images as a grid of tiny pixels where each pixel contains specific color or material information. The print head follows this pixel-based data to deposit material point by point in a raster pattern. This method is widely used in digital imaging and inkjet-based printing processes due to its simplicity, precise control, and consistent resolution. Next, positioning system. The 3D positioning system of a 3D printer governs the coordinated movement of the X, Y, and Z axis, enabling precise control during the printing process. Depending on the machine design, 1, 2, or all three axes may be movable to position the print head or build a platform accurately. The presence of three axes provides depth information to the 3D model, allowing complex shapes to be fabricated. The X and Y axis control lateral movement across the print bed, while the Z axis controls vertical movement for the layer by layer construction. This is the image for positioning system. Here this X, Y, Z coordinate system. These are the three-dimensional Cartesian coordinate system in 3D printing to locate any point in space. The X-axis controls horizontal movement along the width. This Y-axis control horizontal movement along the depth, and Z controls vertical movement for layer by layer building. Next, print head. Printing resolution is a critical parameter in any 3D printing system, as it determines the smallest achievable feature size and dimensional tolerance of the printed part. In 3D inkjet printing, the primary limiting factor for resolution is the droplet size, which is directly governed by the nozzle diameter of the print head. Due to the precise droplet control, the inkjet-based 3D printing is capable of producing high-resolution, conductive and insulating structures using a wide range of functional materials. This figure illustrates the droplets-based deposition mechanism used in inkjet 3D printing. Liquid polymer is applied to the print head where controlled actuation ejects a single microscopic droplet through a fine nozzle. The droplet travels downward and precisely deposited onto the print bed at a predefined location. By repeatedly jetting and placing droplets while the print head scans the surface, continuous lines and layers are formed, enabling accurate layer by layer fabrication with high spatial resolution. Next, the core component of inkjet technology is the inkjet print head, which is responsible for generating and ejecting precise droplets of material. Inkjet print heads are mainly classified into two types based on their droplet generation mechanism. So first one is piezoelectric inkjet print heads, which use electrical deformation of the piezoelectric element to eject droplets, and next one is thermal inkjet print heads. So which use localized heating to form vapor bubbles that force droplets out of the nozzle. So now what is piezo inkjet printer? It uses print heads containing piezoelectric crystals that deform when an electric current is applied. This deformation causes the crystal to expand, generating pressure that forces ink droplets onto the substrate. When the electric current is removed, this crystal shrinks back to its original shape, creating a suction effect that draws fresh ink into the print head for the next droplet ejection. Now, what is thermal inkjet print heads? This uses thin film resistors to rapidly heat a very small volume of ink in the ejection chamber to temperatures above 300 degrees Celsius. This sudden heating creates a vapor bubble that generates pressure, forcing a tiny ink droplets out through the nozzle. The process transfers the printed image contactlessly and with high precision by depositing controlled ink droplets onto the carrier medium, after which fresh ink refills the chamber for the next cycle. Next one is print bed. The print bed is a surface on which material droplets from the inkjet print head are deposited to form each layer of the object. Depending on the printer design, the print bed may remain fixed or move along the linear axis, typically the Z axis, during the printing process. Its primary function is to provide a stable and adhesive surface that supports accurate droplet placement and layer by layer construction. So this is the image of printer bed. Next one is frames. The frame is the foundational structure of a 3D printer, providing overall rigidity and stability to the system. It is designed to support critical components such as the printhead, build platform, and motion systems, ensuring proper alignment during operation. A rigid frame enables smooth and precise movement along the printer axis and helps reduce vibration, which is essential for maintaining accuracy and high print quality. Next one is motion control. Motion control systems and motors play a crucial role in modern 3D printing by coordinating and regulating the movement of all mechanical components. These systems accurately synchronize multiple axes, enhance positional precision, reduce noise and vibrations, and enable higher printer speeds. These systems accurately synchronize multiple axes, enhance positional precision, reduce noise and vibrations, and enable higher printing speeds. Motor provide the controlled motion required for precise positioning of the print head and build platform. High precision motion control is especially important in advanced applications such as bioprinting, where researchers are developing printed living tissues, bones, cartilage, and organs. So this is about the printers. In the next video, we can see about print head consideration. Thank you.